Hello, my name is Jeff La Favre. I'm the head advisor for Geauga Engineering and Robotics 4-H Club. We have about 35 members in our club, and ranging in age from 3rd grade up and through high school. And we've had some members who've expressed interest in building prosthetic arms for people in need. So I thought it would be a good idea if I learned how to build an arm myself. This video is my test model for the Team Unlimited Arm version 2.1 Alpha Edition, downloaded from thingiverse.com, the number 1672381. This is the arm here. It's printed with PET-G at 120% size. I also have a collection of high-resolution photos available at a website that I will submit with my badge request. The arm is printed, I believe I said, in PET-G. The printer used was a Maker Gear M2 V4 Rev E. Some of the challenges that we had in printing the arm were related to PET-G, a new material for me in experience. I found a lot of helpful advice at the Maker Gear forum relating to the PET-G, and followed a lot of that advice for the printer settings. I have detailed printer settings available at the website, along with high-resolution photos of all the parts. Aside from the settings for the printer, the other challenge working with PET-G is the thermoforming. It requires a higher temperature than, say, something like PLA. I found references to the glass transition point ranging somewhere between 75 and 85 degrees centigrade. For some of the thermoforming, we used boiling water, dipping the parts directly into boiling water for about 30 seconds. For the forearm part, we poured boiling water into a oven-proof tray and immersed the forearm for about 2 minutes before forming over a 1.5 inch PVC pipe. One of the things that we had a problem with was the pin over here in the elbow joint on the side where the tension box is. When the arm is actuated, we found that the original pin was popping out here, and we needed to print another pin, custom designed pin using Onshape, and made the pin a little bit larger, the end of it a little bit larger in diameter, a little more squared off. And with that new pin, we found no problems with the pin being pushed out. Let me actuate the arm so you can get an idea of how it works. The way I have it tensioned, it tensions up tight with all the strings at about this angle here, and then when we close it up, fully closed at about that angle on the arm. I'm not sure if that's exactly right. I'm hoping I've got that just about right. I can pick up a half-liter bottle of water with the arm without any problem. Seems to operate fairly smoothly. And as I said, we have a number of high-resolution images of all the parts, the details of the parts on our website. Thank you very much.